Hello everyone, welcome to another Math 5 video. Today we're going to do a couple of example problems. These are going to be word problems, which are problems usually that students have a little bit of trouble with. So we'll do a couple examples to hopefully, get us warmed up for our meeting on Wednesday. Okay, so I found a couple problems in the textbook. This is section 1.1, problem number 63. Okay, so let's go ahead and read the problem. And then we'll try to solve it. So it says two spelunkers, cave explorers, were exploring different branches of an underground cavern. The first was able to descend 198 feet farther than twice the second. If the first spelunker descended 1,218 feet, how far was the second spelunker able to descend? Okay, it looks like there's an extra A in there, a little typo. Okay, but that's okay. So there's two spelunkers, and so we'll call them maybe the first and the second. And what does the statement say? There's one that says the first was able to descend 198 feet farther than twice the second. So if we let S represent the distance that the second spelunker descended, then the first was able to go 198 feet more than twice what the second person did. So the distance that the first spelunker descended is equal to 198 feet more than twice the second. Right? So we can set up an equation that way, and then we have, it looks like two variables is what I've set up. And so if we have two variables, we should have two equations as well. And so we can continue reading. And the next sentence says, if the first spelunker descended 1,218 feet, so F was equal to 1,200. F is the distance that the first spelunker descended, 1,218. How far was the second spelunker able to descend? And I hope I'm pronouncing that right. I think that's how you pronounce it. So here we have two equations with two variables, and we can use the substitution method to solve this. And substitution method basically just substitute. So F can be replaced by 1,218. So this F up here, I'm going to replace by 1,218. And I'm going to write that down below. Oops. I'll write that down below. So 1,218 is equal to 2S plus 198. And now notice once I use the substitution, I now have an equation in a single variable, and I can solve for S. S, remember, is the distance that the second spelunker descended. So I get 2S, and let's do a little subtraction here. 11 minus 9 is 2, 1 minus 1 is 0, and 1. And then we can divide by 2 on both sides. So I'm getting S on one side and 510 on the other side. So it looks like the second spelunker descended 510 feet. Now, we could check this. This is not required as part of our solution, but to check, what can we do? Let's go ahead and double this quantity, because we were told that the first was able to descend 198 feet more than twice the second. So if we take twice the second and then add 198 feet to that, we should get the value that the first spelunker descended. So twice 510 is 1020. And if we add 198, that gives us 1218. And that's exactly what was given to us. Oops. Yeah. All right, so that checks out. And that means, we can box our answer here. This is correct. All right. Let's take a look at another problem here. How about number let's try the next one. That's number 64. It says, I'll read it first. The area near the joining of the Tigris and Euphrates rivers in modern Iraq has often been called the cradle of civilization, since the area has evidence of many ancient cultures. The length of the Euphrates River exceeds that of the Tigris by 620 miles. If they have a combined length of 2,880 miles, how long is each river? Okay, so yeah, let's take a look here. All right. So now it says the length of the Euphrates exceeds that of the Tigris. So I'll put exceeds the length of the Tigris by 620 miles. Okay, so let's go ahead and define a variable to represent the length of the Euphrates. So I'll use the letter L, and I'll write it, I'll write it over here. L represents the length of, and maybe I should have used E. Let me change that. E to length of Euphrates. And then T for length of Tigris. Okay, and so now we can translate this, the length of Euphrates. And then when it says exceeds the length of the Tigris, it means is longer than, right? The length is more than the Tigris by 620. So the length of the Euphrates is equal to the length of the Tigris plus 620. If you add 620 miles to the length of the Tigris, then that is the same, or that's equal to the length of the Euphrates. And then it says, if they have a combined length of 2,880 miles, how long is each river? So the combined length is E plus T, the length of, if I combine their lengths, then I get 2,880 miles. Okay, I'm leaving the units off right now because we don't really want to put the units in the equation. If we can leave them off, that's okay. Okay, so this would be a very good problem to do substitution method for, since one of the variables is already solved for. But since we already did the substitution method on the previous problem, I'll do another method for this one. And that other method is called the addition or elimination method. And what that involves is, let's see, I'll get all the variables on one side, on the left-hand side of the equal sign. So I'll subtract t on both sides. And so I have E minus t. is equal to 620 for one of my equations, and then E plus T is equal to 2880. And then the goal of the addition or elimination method one of the goals here is to make two coefficients opposite of each other. And the two coefficients, they should be on the same variable. So in this case, actually, it turns out it's already occurred just by moving the t over to the left-hand side. Notice the coefficient of t in my first equation is -1, and the coefficient of t in the second equation is +1. And since they're opposite each other, I can now add these two equations, just adding down the like terms, and I would get 2e. Notice minus t and plus t cancel each other out. That's why it's also called the elimination method. When I add the two equations together, I eliminate one of the variables. And then if I add here, I get 0, 0, 14, 15, 3. So 2e equals 3,500. And then I can just divide by 2. Notice now that I've added these equations together, I eliminated one of the variables. I have a single variable that I can solve for now. And so if I divide both sides by 2, I now get E is equal to 1,750. And so we have one of the lengths of the rivers now. Let's go ahead and find the other. So here's one length. The question did ask me for the length of each river. And so I can go ahead and plug in to one of my equations. Let me write my original equation. E is equal to t plus 620. And I will plug in my value of E here. So 1750 equals t plus 620. And if I solve for t, let's see what I get. 0, 3, 1, 1. So I have the value of t now, and I can give my answer as the length of the Tigris and Euphrates, or the lengths of Tigris and Euphrates are 1,130 miles and 1,750 miles, respectively. And respectively, of course, we mean by that the length of the Tigris, since Tigris was listed first, this first length given is the one for the Tigris. All right. So we could check our answer, adding these two up and see if we get the correct sum. They should add up to 2880. If you can do a little bit of mental math, you can see that that's true. And then you can also see if the Tigris plus 620 is equal to the length of the Euphrates. You can also do a little bit of mental math and see that that's true as well. Okay, so that's two problems there. Yeah, maybe we'll take a look at one more. Okay. Trying to find a good one. One that is similar to the problems that we have on our worksheet. So let's go ahead and find one more. let's try, yeah, we'll try the next one, 65. Okay. Let's see here. So this is 65. It says US postal regulations require that a package can have a maximum combined length and girth of 108 inches. A shipping carton is constructed so that it has a width of 14 inches, a height of 12 inches, and can be cut or folded to various lengths. What is the maximum length that can be used? Okay. And they give a nice little picture here. So let's go ahead and draw that picture. Something like this. Okay. And so the length is this dimension here. The width is here. And the height is this dimension here. Okay, so it says the maximum combined length and girth distance around of 108 inches. Okay, so let me write down L plus G, the length and girth of 108 inches, so equals 108. This is the maximum allowable, and it says girth is distance around. And so how do we calculate that? Well, if you look at the picture, G, the girth will be, and I can highlight here. And this distance, that's W plus H here. And then you can also see that, there's going to be another one in the back. And, hopefully that's clear from the picture. So G is going to be equal to width plus length plus width plus length. And so you can see that that's 2W plus 2L. Okay, so let me write that equation a little bit more, a little cleaner here. G is equal to 2W plus 2L. And so it looks like here, do we have two equations? There's a little more information that's given, right? A shipping carton is to be constructed so that its width, it has a width of 14 inches. So let me go ahead and substitute that in place. The width I can replace with 14 inches and a height of 12 inches. Okay, so I've actually made a little mistake here. Hopefully you caught that. When I wrote the equation for girth, it is width plus height, right? So we're going around, and let me highlight it here. Width plus height plus width plus height. So just a minor little change here. These L's should be H's. Okay. You can tell I didn't do this problem ahead of time. That's okay though. I mean, you're seeing the problem solving process here. And so then we have 2 times the height, which is 12 inches. Okay. Okay, very good. Now, this L, I just want to point this out in case anybody's wondering, this L is correct, right? That one was correct because that is the combined length and girth. L and plus G is a maximum of 108. Okay, so Um, okay, so then it says it can be cut or folded to various lengths. So the L, the length, is what's variable here. Okay, so this one's not too bad actually. We can just simplify this G equation. G equals 28 plus 24. Add these together, 40, 52. And then it just requires substitution. Yeah, it's not too bad at all, actually. I was hoping for a more challenging problem. Maybe we can do one more if, if everybody, well, if you don't want to watch it, you don't have to. This one here is not too bad. Just do substitution. L plus 52 equals 108. We can subtract on both sides. And then L is equal to 56. Okay, so the maximum allowable length for this, these dimensions that have already been given is 56 inches. Okay, and that's the answer to that one. Okay, so these problems are not too bad. I, yeah, I know that some of these problems over here are a little bit more challenging. So we'll do one of these more challenging problems. I don't want to do any mixture problems because these are challenging also, and I don't think that they don't come up on the worksheet. So that'd be, might not be the best use of our time. So let's just choose one of these uniform motion problems. How about number 74? This will be the last one for sure. Okay, so number 74. If you happen to see some of these mixture problems on Alex, they're not on the worksheet, but they end up coming up on Alex. Feel free to come into office hours and get some help there. Okay, so 74, last one. A plane flying at 300 miles per hour has a 3-hour head start on a chase plane, which has a speed of 800 miles per hour. How far from the airport will the chase plane overtake the first plane? Okay, so here we have two planes, and let's just call them, first plane, and then a chase plane, right? Why not? We could call it second, whatever we like. And it looks like we are given distances and times. Let's see, what were we given? Oops. Sorry, I wasn't showing what I was writing there. Haven't written much. It says a plane flying at 300 miles per hour. So we're given rates. It looks like in miles per hour of these planes. So the first plane has a rate of 300 miles per hour, and it has a 3-hour head start. We'll come back to that. Then the chase plane has a rate of 800 miles per hour. And now it says, how far from the airport will the chase plane overtake the first plane? So we're given a rate. We know the equation distance equals rate times time. That's probably what we're going to be using here, especially since we were given this 3-hour head start. That tells us something about the times that they travel. And then there's a little bit of information there about distance, but we'll talk about that in just a moment. So going to times, we're told that the first plane has a 3-hour head start. So the way that we could interpret that is if the first plane has a 3-hour head start, then let's say that the chase plane has been traveling for, some time t. How much time has the second plane been traveling for? we could say it's been traveling for t plus 3 hours, right? Since it has a 3-hour head start, it will have been traveling 3 more hours than the chase plane. Okay, and you can substitute values in for t to check this. If t is equal to 1, then t plus 3 is 1 plus 3, and that's 4. That makes sense because if the second plane is traveling for 1 hour, then the first plane has been traveling for 4 hours because it started 3 hours earlier. Okay, and then since we know that distance is equal to rate times time from this formula that we have from before, we can fill in our distance little boxes here by just multiplying the rate of each of these planes, 300 times t plus 3, and then 800 times t. Okay, so I just multiplied across there. And now these expressions that are in this distance category represent the distance that each plane has traveled. It's just the rate times the time. And the question asks, how far from the airport will the chase plane overtake the first plane? So if you imagine, of course, the second plane is going faster. So here's the first plane. I'll just put F here. And then here's the chase plane. Since it's traveling faster, eventually it's going to overtake, it's going to pass the first plane. And so at the moment that the chase plane is passing the first plane, they have traveled the same distance, right? Their distances will be equal. Their distances traveled will be equal. So we can set the distance, plane 1 has traveled equal to the distance the chase plane has traveled. This equation here, the distance that plane 1 traveled, should be equal to the distance that the chase plane has traveled at the moment that it's being overtaken. So that means 300 times t plus 3 is equal to 800 t. And then we can solve here. This is 300 t plus 900 is equal to 800 t. I'll subtract 300 t from both sides. And so I get 900 equals 500 t. And then I can divide by 500. T is equal to 9/5. Now, what is t? T is the amount of time that the chase plane travels, right? So this is in hours, and this is, well, we can leave it as 9/5 hours. That's okay. Did we want the time that the chase plane travels? What were we looking for here? The question says, how far from the airport will the chase plane overtake the first plane? And so we can plug in this value of t into this expression here. That would represent the distance that the chase plane traveled until it overtook the first plane. So let's go ahead and plug in there. I'll switch to blue. So 800 times 9/5, and this is equal to, let's go and see, 5 goes into 800, how many times? 160 times. And then 160 times 9, I believe, is 1,440. And this is now in the distance column, so this should be a number of miles. Okay. To check this, we could also plug in this value of t in this expression up here, because remember the distances of these two planes at the point of being overtaken will be exactly the same. So let me plug in 9/5 over there as well. And I'll write that here, 300 times 9/5 plus 3 And so what do we get? Let's see, I'll distribute. I get 300 times 9 over 5 plus 900. And then 5 goes into 30 6 times, so leaving us with 60. 6 times 9 is 54 with a 0 on the end. And then 900 plus 540 is 1,440 miles. So we've verified it there. And we can now say the chase plane, or even both planes, yeah, the chase plane overtakes the first plane 1,440 miles from the airport. Okay, so a couple examples there, just to give you an idea of how some of these problems go. We want to organize our information in, maybe a table or in some way, write out, what our variables mean. If we're using L for length, that's pretty obvious there. T for time, time here in this table that I've made, T represents the time for the chase plane, right? Because it's in the row and column. You can identify it that way. If we don't set up a table, we could define our lengths as, E, as I did here, is the length of the Euphrates, T is the length of the Tigris, and so on. Okay, so try to organize your information and then set up an equation as you've seen in these examples. Okay, so every problem is different. You can see every one of these problems was solved, somewhat differently. So it does take a lot of practice, and that's what we'll do in class. Okay, thanks for watching. Leave a like on the video if you liked it. Leave a comment if you want to say something about the video. And yeah, so I'll be happy to read those comments. All right, so I'll see you in class. Bye for now.